Alright, here we go. We're going to be working on Unit 5, the first section. Remember, double check the objectives and read the information here at the intro when you start working on your outline. Network protocols, media, and devices. We're going to give you an overview of those and talk a little bit about the specifics. In terms of protocols, those are the rules for communications. Okay, how can one device, let's say your smartphone, how can that talk to another device, say the access point? Or how a PC hooks into some type of a switch. How do they communicate? And then how do these devices all communicate through two servers? And those servers could be either locally at your work or maybe servers out on the internet. We follow some type of rules. They have protocols that state the rules, and it varies. There's lots of them. There's a different protocol for getting the information from here to here, and a different protocol from here to here, and so forth. And then we have those two connected, and then going out into the world. You might think of it similar to the mail system. We got a letter, we have to put information in a certain spot, we have those rules, and then we can mail the letter so some other mail location can forward it on because we're following the same rules. Bandwidth. How many bits per second? This is a review, but it's very important because a lot of times we pay for our communications based on how many bits per second we can send. Now this is a quantity, okay? It's those ones and zeros, you know, whatever it might be. It's how many of those we can send based on a piece of time every second. And so we have different bandwidths for our communication to the internet. Our ISP will guarantee a certain amount of bandwidth. And then what's different though, is when you talk about how many bytes of information. So let's say you have a 3 gigabyte data plan for your phone. Here they're literally talking about quantity, how much data is sent. Not how fast you're sending it, but the amount of data that you're sending up through, and they keep track of that and then eventually charges you if you go over that. Okay? How we send the data, we have transmission media, and I realize this is a review. We can send it across wire, and so that could be twisted pair or coaxial cable are the two most popular now. And this is reliable. Once you're connected wire, through the wire, it's pretty reliable. Fairly secure, not perfect, but fairly secure. Somebody would have to tap into the wires. And it works with pretty good bandwidth. Okay, we just talked about the word bandwidth. You can get a good bandwidth, a consistent one, out of wired. Okay? Expense-wise, not too bad. It's a little initial cost getting the wire in, but once it's there, not a lot of cost and upkeep and so forth. Wireless is becoming extremely popular. The speeds are really increasing. Now, we'll talk a little bit here about protocols. So, in wireless, we have this 802.11. And then we have all these categories. There was A, B, and then there was G, and then we went to N, and then AC, and in the future we may have AD. These two are the popular ones now, but this keeps changing so fast. These are very fast and very good, but a lot of places still run on G, because if you're going to do this, you got to increase the equipment. wireless, we send it through the air, so we have this wave we send through the air. Cost-wise, this isn't real expensive either, and compared to having to wire a building, it could be way cheaper. Okay, the signals are in the air. That can be an issue. Okay, you know, being able to get the signal to your device and so forth. And this would be a higher security risk in terms of security, having the signals in the air. Our best form of communications, fiber optic, we use light to send the signal, so that is extremely fast. Really good security. Probably could be the most expensive to get the fiber optic to the right location, but a lot of small phone companies are laying fiber all over. And so when you hear about fiber getting to somebody's house, that is good. That's a real positive. You may not see it right now, but in the future, that'll be the key. That'll be better than either of these two, wireless or wired methods of communication. All right, I'm going to slide it up. I'm going to run through the next couple things fairly quick. So we have these types of devices here. So we talk about intermediate network devices. We'll talk quite a bit about those throughout the entire part of communications. We have these modems, modulator, demodulators. They are used to have, let's say you have a cable modem right here, and you have your connection inside your house, and then we have, let's just say, this connection outside that goes to your provider. This takes a signal from in here and makes it work on the wire going this way. If it's a cable, then, you know, we talk about broadband. They can have both data, your internet, and your TV on it, both on that same cable, and that runs to your provider. Your provider, that coaxial cable turns into fiber somewheres, whether it's near or a little ways from your location, and then it runs fiber back to them, and they connect you in. Okay, so modems are used a lot, modulator, demodulators. In networks, we have switches. The diagram looks like this, in which we can connect devices to that, like a PC, and then that PC can communicate to the switch through a protocol. We talked about protocols. It's the same thing. We have protocols up here too. And then that switch is an intermediate device that can move it, and we can have lots of computers connected to that, and the switch can figure out which is which based on something we'll learn more about later on, is a MAC address, the physical address in the device, which is unique to all devices, even your phone, your laptop, and so forth. So this can get the information back to the end user device, which we're going to talk about down here in a little bit. Access points, they are used, we could say here's an access point here. They're used to communicate with wireless devices, and then they're usually connected into some other intermediate device like a switch, which then eventually moves a signal further into the network. And then the last one we're going to mention here are routers. Draw a picture like this. They're able to take information from one network and send it to another network. They're what make up primarily the internet, how the communications go through the internet. They look at both an IP address, which is a logical address, and they use, to access the router, you might use a MAC address, but their key thing is IP address, and they create the best path to send information through a network. And you might think, so, well, I bought a little router for my house. We're going to talk about that just in a little bit. Because it actually, that little router you buy at your house, it does act like a router. If it's wireless, it acts like an access point, and most of them have a way to connect switches to it. So that device then connects to the modem, which connects you to your provider. Network end devices, we have personal computers, we have laptops, mobile devices, personal computers. They might connect into a switch, like right up here. A laptop could connect into the switch, or a laptop could go wirelessly to an access point. Mobile devices, almost always wireless to some device. Smartphones, tablets, watches. Now watches sometimes might connect to your smartphone, and then the smartphone connects to an access point. Printers are connected to a network, servers, and there can be a huge amount of other things connected to a network, especially if you're talking about a manufacturing location or whatever. So let's just take a look at a picture here then to finish this up. So let's say this is the internet, and the internet, the devices in there, routers connected and communicating with each other. They have all different kinds of paths to get through. We'll talk more specifically about the internet later on. And so then there can be a company somewheres, and they could have in there a server, lots of storage and so forth. And that server then can be connected to a switch and then eventually connect out into the internet. So you might have a cable modem at home. That's an intermediate device. That connects to your ISP, your provider. And then you might have one of those little, what they'll call them routers, but they're really a router, a switch, and so forth. That's another intermediate device. And that can connect to your smartphone. You can connect to your laptop. Maybe it's directly connected to your television. Could be. Directly connected to your console, your game console, and maybe connected to your laptop. So these are end devices that get into the network. Okay? And they allow you to move through and communicate to other end devices like a server. Or you may have, like in our house, we have a printer connected wirelessly. And so that's an end device also. In a business, or like at NIACC, we have labs and the computers are connected to switches. So we have all these end devices. Or at NIACC, you could be connected, your phone or your laptop could be connected wirelessly. And then these intermediate devices connect eventually out to the internet or to other servers, to other servers there at campus, which can be end devices too, connected in. So we have all the intermediate devices that allow us to connect all these end devices. And that's it.